This video is for section 8.3 about finding the inverse of a matrix. So the concept in this section is inverse. And this connects to the idea of inverse from algebra. For example, the additive inverse of the number 8 is -8, because when you add these together, it creates the additive identity value for real numbers, which is 0. 0 is the number you add to any number and not change the value of that number. In algebra, you also learned about multiplicative inverses. For example, the multiplicative inverse of 4 is 1/4, because when you multiply them together, that creates the multiplicative identity value for real numbers. 1 is the number that you multiply to a number to not change its value. In algebra, you learned about inverse operations. If you have a number x and you add 5 to it, the inverse operation is subtracting 5, because that creates the original number x. Adding 5 and subtracting 5 are inverse operations. The inverse of multiplying by 3 is to divide by 3. The inverse of squaring is to square root. So we have a lot of experience with inverses in algebra. Matrices can have inverses as well. Inverse matrices are two matrices that multiply together to create the identity matrix, just like multiplicative inverses are two numbers that multiply together to create the multiplicative identity 1. Here's an example of that. Here is a 2 by 2 matrix. Maybe this matrix is represented with a capital A. It's being multiplied by this other 2 by 2 matrix. Maybe that's represented with capital B. Are A and B inverses? To be inverses, when you multiply them, it must create the identity matrix. Let's multiply these and see what matrix is created. First of all, can a 2 by 2 be multiplied by a 2 by 2? Yes, because those numbers match. And the answer matrix is 2 by 2. Let's follow the multiplication process from the previous lesson. -1 times 1 is -1, plus 2 times 1 is 2. This makes 1. Now we'll get the upper right number. -1 times -2 makes 2, plus 2 times -1 is -2, and those add up to 0. Now we'll get the bottom left number. -1 times 1 is -1, plus 1 times 1 is 1, and these add up to 0. And now we'll get the bottom right number. -1 times -2 is 2. 1 times -1 is -1, and these add up to 1. This matrix that has a diagonal of 1s and 0s in the other two positions is the identity matrix. Because matrix A multiplies to matrix B to create the identity matrix, we think that A and B are inverses. However, we have to check that B times A also would make the identity matrix, because for two matrices to be inverses of each other, when multiplied together in either order, it has to create the identity matrix. So to check that A and B really are inverses, we need to now multiply B times A. Let's do that here. Here's matrix B. Here's matrix A. A 2 by 2 multiplied to a 2 by 2 creates a 2 by 2. Let's get the top left number. 1 times -1 is -1, plus -2 times -1 is 2, and that adds up to 1. Now we'll get the top right number. 1 times 2 is 2. Negative 2 times 1 is negative 2, and that adds up to 0. Now we'll get the bottom left number. 1 times negative 1 is negative 1. Negative 1 times negative 1 is 1, and that adds up to 0. And now the bottom right number. 1 times 2 is 2. Negative 1 times 1 is negative 1, and this adds up to 1. This is the identity matrix. Because A times B and B times A both create the identity matrix, A and B are inverses. The matrix containing negative 1, 2, negative 1, 1 is the inverse of the matrix containing 1, negative 2, 1, negative 1. The same symbol that means inverse when working with functions is used to indicate the inverse of a matrix. A with a negative 1 in the corner means the inverse of matrix A. In the example problem that we looked at, we were given two matrices and asked to find out if they were inverses. And we did that by multiplication. A times B, and then also B times A. But what if you're asked to find the inverse of a matrix? How do you do that? Let's discuss that next. Let's say that matrix A is a 2 by 2 matrix containing these four entries: A, B, C, and D, where these four letters are representing numbers. Then A inverse is found by going 1 divided by A times D minus B times C times a matrix that contains as its four entries D, A, negative B, negative C. This math formula is what we use to find the inverse of a 2 by 2 matrix. Let's say we have a matrix called matrix X, and it contains these four numbers: 2, 3, negative 1, and 6. And we want to find the inverse of matrix X. We're going to use our math formula. 1 divided by A times D. A is the upper left number, D is the bottom right number. That means to go 2 times 6. That's 12. Minus, and then the formula says B times C. That's the upper right number multiplied by the lower left number, that diagonal. 3 times negative 1. That makes negative 3. Then multiply by a 2 by 2 matrix. The formula puts D here. What was D? D was the number in the bottom right corner. In our problem, that's a 6. Then it says negative of B. Take the negative of this number. So the negative of 3. Then the formula has a negative C in this position. Here's where C is located. Do the negative of this number. So the negative of negative 1. And then put A here. Well, what was A? A was the number in the upper left corner. So in our problem, the 2. Look what's happened in this matrix. We have switched these two numbers, and we have changed the sign of these two numbers. Now let's continue working this out. We have 1 over 15 multiplied to the 2 by 2 matrix. And now we can distribute this scalar to all four entries. 1/15 times 6 makes 6/15, which reduces to 2/5. 1/15 times negative 3 makes negative 3/15, which reduces to negative 1/5. 1/15 times 1 is 1/15, and 1/15 times 2 is 2/15. This matrix is the inverse of matrix X. If you multiply them together in either direction, it will create the identity matrix 1, 0, 0, 1. This method of finding the inverse of a 2 by 2 matrix uses a math formula. There's another way to find the inverse of a 2 by 2 matrix using Gaussian elimination. Let's take a look at that other method. And as our example, we can use matrix X again. I'm going to write matrix X. Then make a dividing line, and on the right side, put the identity matrix. This is an augmented matrix. Next, I'll perform row operations until I've transformed the left side into the identity 1, 0, 0, 1. While performing those operations, the values on the right side of the divider will change. Let's work through those steps. As one of my transformations, I'm going to multiply -1 times row 2, because that will create a +1 here instead of a -1. And I will switch the two rows. I'll have 1, -6, 0, -1. And the second row will be 2, 3, 1, 0. For my next operation, I'm going to go -2 times row 1 and add it to row 2 to create a new row 2. This operation will not change row 1. -2 times 1 is -2. -2 add 2 is 0. -2 times -6 is 12. 12 add 3 is 15. -2 times 0 is 0. 0 add 1 is 1. -2 times -1 is 2. 2 add 0 is 2. For my next operation, I'm going to row 2 and divide it by 15 so that this number turns into a 1. When performing that operation, the first row will not change. 0 divided by 15 is 0. 15 divided by 15 is 1. 1 divided by 15 is 1/15. And 2 divided by 15 is 2/15. Next, I want this to turn out to be a 0. To do that, I can go 6 times row 2 and add it to row 1 to create the new row 1. When performing that operation, row 2 will not change. Six times 0 is 0. 0 add 1 is still a 1 here. 6 times 1 is 6. 6 add -6 creates the 0 there that I was hoping for. 6 times 1/15 is 6/15, which reduces to 3/5, and 3/5 add 0 is 3/5. And 6 times 2/15 is 12/15. 12/15 reduces to 4/5, and 4/5 added to the -1 is -1/5. The left side has been reduced to the identity, and the right side has created the inverse. Notice those 4 entries and compare them to those 4 entries. We got the same answer. So one way to find the inverse of a 2 by 2 matrix is with a math formula. The other way to find the inverse is using the Gaussian elimination on an augmented matrix. Remember that when using Gaussian elimination, sometimes you create the situation that there's no solution. So it's possible that a matrix does not have an inverse. That same result can come from the formula. This portion of the formula, in which you multiply the A times D and subtract the B times C, could turn out to be a 0. And we know we can't have 1 divided by 0. So if you ever do get a 0 here in the denominator, That's the situation where a matrix has no inverse. Both of these methods work well for inverse matrices. Most students prefer the math formula, so why would you ever use method 2? Because if you want to find the inverse of a 3 by 3 matrix, then there is no formula. You need to use the Gaussian elimination method. Let's do an example of that. Here is a 3 by 3 matrix. Let's find its inverse. We don't know a formula that works to find the inverse of a 3 by 3, so we'll make an augmented matrix and use Gaussian elimination. Here's the augmented matrix. Our original 3 by 3 matrix is on the left side of a dividing line, and the identity matrix for a 3 by 3 is on the right side of the dividing line. Next, let's transform this into the identity. We could go -1 times row 1 and add it to row 2 to create a new row 2. And to save writing, let's also go -6 times row 1 and add it to row 3 to create a new row 3. Neither of these operations will change row 1. -1 times 1 is -1. -1 add 1 is 0. -1 times -1 is 1. 1 add 0 is 1. -1 times 0 is 0. 0 add -1 is -1. -1 times 1 is -1. -1 add 0 is -1. -1 times 0 is 0. 0 add 1 is 1. -1 times 0 is 0. 0 add 0 is 0. Now we'll work on row 3. -6 times 1 is -6. -6 add 6 is 0. -6 times -1 is 6. 6 add -2 is 4. -6 times 0 is 0. 0 add -3 is -3. -6 times 1 is -6. -6 add 0 is -6. -6 times 0 is 0. 0 add 0 is 0. -6 times 0 is 0. 0 add 1 is 1. Next transformation. We want this to be a 0. So we can go -4 times row 2 and add to row 3. When performing this operation, the first and second rows will stay the same. -4 times 0 is 0. 0 add 0 is 0. -4 times 1 is -4. -4 add 4 is 0. -4 times -1 is 4. 4 add -3 is 1. -4 times -1 is 4. 4 add -6 is -2. -4 times 1 is -4. -4 add 0 is -4. -4 times 0 is 0. 0 add 1 is 1. The next thing we want is for this position to be a 0. So we can go row 2 added to row 1 to create the new row 1. To save writing, let's also turn this one into a 0 by taking row 3, adding it to row 2 to create a new row 2. We're going to do this operation first, then this operation. The only row that will stay the same after doing both of these is row 3. Here we go. Row 2 plus row 1. 0 plus 1 is 1. 1 plus -1 is 0. -1 plus 0 is -1. -1 plus 1 is 0. 1 plus 0 is 1. And 0 plus 0 is 0. Next, we'll do row 3 plus row 2. 0 plus 0 makes 0. 0 and 1 is 1. 1 plus negative 1 is 0. Negative 2 and negative 1 is negative 3. Negative 4 plus 1 is negative 3. 1 plus 0 is 1. We almost have the identity. The only number that's not correct is this one right here. We need this to be a 0. So as our final operation, we can go row 3 plus row 1 to get the answer. The second row of numbers will stay the same. And the third row will stay the same. 0 plus 1 makes 1. 0 plus 0 makes 0. 1 plus negative 1 makes 0. Negative 2 plus 0 makes negative 2. Negative 4 plus 1 makes negative 3. And 1 plus 0 makes 1. The left side of the augmented matrix has changed into the identity. The matrix on the right side is the inverse. So here was the original matrix. Here is its inverse. If you multiply them together in either order, it creates that 3x3 identity matrix. This concludes the video about inverse matrices.